Right now, at this exact second, 8 minutes of sunlight are traveling toward your fate. That delay is not a detail, it is a death sentence, and you will understand exactly why before this is over. The sun does not have to explode to kill everything on Earth. It does not have to burn out. It does not have to expand and swallow us. It only has to vanish, silently, without warning. And for 8 full minutes after it happens, you would feel nothing. See nothing unusual. Your coffee would still be warm. You would not know the world had already ended. And there is something even stranger at work here. Something that challenges the most fundamental assumption you have ever made about gravity, about why the planets move at all. This is not a disaster movie scenario. This is hard physics. And the answer will change how you understand the universe you are living in. Let us be precise about what we are asking. The sun is not going to collapse into a black hole. It lacks the mass. When it dies, in roughly 5 billion years, it will swell into a red giant, exhale its outer layers as a planetary nebula, and leave behind a quiet white dwarf, a cold ember. But the question is not will it, the question is what if it did? Because the hypothetical is not idle curiosity, it is a surgical instrument. Strip away the sun's light, its warmth, its gravitational presence as we understand it, and you are left with the most naked version of physics there is. The sun accounts for 99.86% of all mass in this solar system. Every planet, every moon, every comet traces an orbit that is entirely a consequence of that mass, curving the fabric of space-time. The orbits are not held in place by some ongoing force pulling outward. They are the natural shape of space itself, bent by the sun's presence. This is the part most people get wrong. And it is why the collapse scenario is so unsettling. Remove the sun, replace it, instantly hypothetically, with a black hole of identical mass. And the question becomes, what actually changes? Before we answer that, we need to go back to 1687, because Isaac Newton nearly got this catastrophically wrong, and the man who corrected him would not be born for 2 more centuries. Newton's theory of universal gravitation described gravity as an instantaneous force, a pull that acted across infinite distance with zero delay. If you moved the sun, Earth would feel it immediately. Every point in the solar system would respond at the same instant. This was not a minor assumption. It was the foundation of celestial mechanics for over 200 years. It was also, as Einstein demonstrated in 1915, completely false. Einstein's general theory of relativity replaced Newton's instantaneous pull with something far stranger and far more beautiful. Gravity is not a force transmitted through space. Gravity is space, a curvature in the 4-dimensional fabric of space-time produced by mass and energy. And changes in that curvature do not propagate instantly. They ripple outward at exactly the speed of light. We have now heard those ripples. On September 14, 2015, the LIGO detector in Hanford, Washington, registered a distortion in space-time measuring less than 1,000th the diameter of a proton, the gravitational wave signature of 2 black holes merging 1.3 billion light-years away. Kip Thorne, one of the physicists behind the detection, described the moment as hearing the universe speak for the first time in a language we had never used before. If gravity travels at the speed of light, what happens to Earth the moment the sun collapses? Here is where physics becomes merciless. The sun sits approximately 150 million kilometers from Earth. Light and gravitational information covers that distance in about 8 minutes and 20 seconds. The moment the sun collapses into a black hole, a gravitational wavefront begins propagating outward at the speed of light. It has not reached us yet. For 8 minutes and 20 seconds, Earth continues its orbit as if nothing has happened, because for Earth, nothing has happened. The old gravitational field is still in place. The curvature of spacetime that defines Earth's path has not yet received the update. This is not a metaphor. It is the literal physical structure of causality. Nothing, not information, not force, not reality itself, can travel faster than light. So Earth continues its elliptical arc. The other planets continue theirs. Mars, Jupiter, Saturn, all still orbiting the ghost of a star that no longer exists. For those first 8 minutes, the solar system is running on memory. But here is the revelation that most people miss entirely, and it is perhaps the most counterintuitive fact in all of astrophysics. When the gravitational wavefront finally arrives, Earth does not fly off into space. If the black hole has the same mass as the sun, and in our hypothetical it does, then the curvature it produces in spacetime is identical. Earth's orbit does not change. Mars's orbit does not change. The planets continue exactly as before, tracing the same paths they always have. The black hole does not pull harder, it pulls identically. Mass is mass. The geometry of spacetime does not care what form that mass takes. This is the gift Einstein gave us. The ability to see that gravity is not about fire or light or the physical shape of an object. It is purely about mass and mass alone. But let us stop talking about orbital mechanics for a moment, because the real story here is not what happens to the planets. It is what happens to you. 8 minutes and 20 seconds after the sun collapses, you feel the warmth leave the sky. Not gradually, not slowly, as in a sunset. Instantaneously, the light stops because it has already stopped at the photons already in transit, the last 8 minutes of sunlight, arrive in their final wave, and then nothing follows. The sky does not go dark gradually. It goes dark the way a light switch, except it is not a switch being flipped off. It is the last 8 minutes of a star's output arriving all at once, and then silence, visual silence. A darkness that has no dawn behind it. At roughly 270 degrees Celsius, the cosmic microwave background becomes the ambient temperature of the universe. Earth's surface, stripped of solar heating, begins a temperature decline that within days drops global averages below 50 degrees Celsius. Within weeks, surface oceans begin to freeze. Within a year, the atmosphere itself, starting with carbon dioxide, then oxygen, then nitrogen, begins to freeze out of the sky and settle as layers of ice on the surface. Psychologists who study extreme environments, Antarctic isolation, submarine confinement, long-duration spaceflight, speak of a phenomenon called break-off. It occurs when an individual, usually at high altitude or in conditions of total sensory deprivation, experiences a sudden and overwhelming conviction of utter cosmic aloneness. Astronaut Frank White, who interviewed dozens of space travelers after their missions, documented what he called the overview effect, a psychological rupture that occurs when humans see Earth from outside it for the first time. The fragility, the improbability, the silence. Now imagine the inverse. Not viewing Earth from outside, but standing on the surface of Earth and watching the star that made all of this possible disappear in an instant. Edgar Mitchell, Apollo 14's lunar module pilot, once said that the experience of standing on the moon and looking back at Earth filled him with a certainty that the universe was in some way conscious. He returned to Earth changed. He spent the rest of his life trying to explain what he had seen. What would that moment, the moment the sun vanished, do to the collective human psyche? What would it mean to watch the thing that made you possible simply? There is an argument, a quiet, uncomfortable argument among certain philosophers of science, that humanity's entire psychological architecture is built on the assumption of solar permanence. Every human civilization has worshipped, feared, tracked, and organized itself around the sun. The Egyptians saw it as Ra, the self-creating god, the source of all creation. The Aztecs fed it blood to keep it moving. Every culture on every continent has a solar mythology because, at some level of deep human understanding, we have always known that the sun does not stop, or everything stops. To see it stop would not merely be a physical catastrophe, it would be the extinction of meaning itself. But here is what no one talks about, and this is the part that keeps astrophysicists genuinely unsettled. The sun's gravitational effect on Earth is not the only thing traveling at the speed of light. The sun also produces a constant stream of charged particles, the solar wind, that shapes Earth's magnetosphere, deflecting cosmic radiation. It produces neutrinos in such staggering quantities that 65 billion of them pass through every square centimeter of your hand every second. It bends light passing near it. It anchors the entire architecture of the inner solar system. All of those effects, every single one, would also vanish at 8 minutes and 20 seconds. And there is something even deeper. Something that requires us to go back to Einstein one final time. When a star collapses into a black hole, it does not do so silently. The process, even in our hypothetical instantaneous version, would produce gravitational waves of extraordinary power. A ripple in space-time propagating outward from the point of collapse at the speed of light, carrying energy of a magnitude that makes the LIGO detection look like a whisper. When that wavefront reached Earth 8 minutes and 20 seconds after the event, it would pass through the planet, through you. Every atom in your body would oscillate infinitesimally as space-time self-flexed. You would not feel it. The distortion would be far too small. But you would be, in the most literal possible sense, touched by the death of the sun. You would be changed by it at the atomic level before you even saw the darkness. The light would still be arriving, the sky would still look normal, and the wavefront of the sun's death would already have passed through. This is what physics actually says, not metaphor, not poetry. The factual, measured mathematical truth of a universe where information travels at a finite speed and causality is not a guarantee but a structure that, for one 8-minute window, would leave the entire solar system living in a world that had already ended. There is a word for this in physics, a light cone, the boundary between the events that can affect you and the events that cannot yet. For 8 minutes and 20 seconds, the death of our star would be outside your light cone, uneachable by knowledge, by sensation, by any instrument ever built, and then it would arrive. The sun is not going to collapse, but it is going to die. And the manner of its death, the quiet swelling, the long exhalation, the slow dimming, will in some ways be harder to comprehend than the sudden violence of a collapse, because it will happen on a timescale that makes human history look like a single heartbeat. And the Earth will be swallowed not by darkness, but by light. What we have learned today is not really about black holes. It is about the architecture of reality itself, about what it means to live in a universe where the speed of light is not just a speed, it is the border of now. It is the wall between what is already true and what you are still allowed not to know. The sun's death is written. It is in physics. It is in the hydrogen budget, in the mass calculations, in the stellar evolution models we have run 10,000 times. and always arrive at the same answer. The only question is what survives. If you want to understand what actually happens in the final billion years of Earth, what the red giant phase looks like from the surface, what the science says about whether life could possibly adapt or escape, and why one small detail in the stellar models suggests the timeline might be shorter than we think, that is the next one. Do not look away.